When we are writing the equations for transformed sine and cosine functions, we are always comparing the values to the parent. So for the y equals sine of x, we need to know that it has a key point here at 0, 0, and it has 2 pi for its period. It has an amplitude of up 1 and down 1. For y equals cosine x, it has a key point here at 0, 1. That's a maximum, a 2 pi period, and again the amplitude's up 1 and down 1. When we're trying to identify the period, by that we mean the entire cycle of values. So here you're measuring the distance on the x-axis. It starts at 0, 0, goes up all the way down to the minimum and comes back to 0. And on cosine, from that 0, 1 position down to its minimum and back up to that 0, 1. Again, that takes 2 pi. For amplitude, each time we're comparing how high and low the graph goes compared to its parent. Amplitude for the parent is up 1, down 1 for both. If it's up 3 and down 3, we'll say the amplitude's 3, and we'll include that new number in our equation. For sine and for cosine, originally there's no phase shift or horizontal shift. Track the location of the 0, the y-intercept there, to identify how far it moves. Here you can see if that key point moved from the origin, we measure that distance to identify our phase shift or horizontal shift value. For cosine, it has a maximum at 0, 1, so we will track the how far that maximum is from that original position to identify the phase shift. Here you'll see the movement. Okay, so we're tracking that point to identify the phase shift. Here we compare this graph to the parent function, y equals cosine x. It still has a 2 pi period, a max at 0, 1. The only difference is an amplitude of 2. So when we write up the equation, we write y equals 2 cosine x. If the graph is flipped over, as in this case it's flipping, the amplitude is still 3, but since instead of going up initially it goes down, we include that negative sign in front of the amplitude value. When we measure the distance on the graph for either of the functions run through a complete set of values, we'll use that information with this formula to figure out that constant value b we need for the equation. So measure the period on the graph and use 2 pi divided by that period. That will give you your b constant. Here we measure the period and it ends up as 4 pi divided by 3. So we're going to use that period to calculate that value b we need for the equation. See here, I'm just putting the period in there in that little spot for period. So we have 3/2 for b, and then we see it goes up 2 and down 2. So we can write that up as y equals 2 sine 3/2 x. From the graph, 0, 0 movement or 0, 1 movement to identify the phase shift, the x-coordinate of that will be the c value that we're looking for. So here, the 0, 0's moved 1/2 pi away, amplitude of 1, we put it there. If there's also a period adjustment, we'll need to do c divided by b in that spot.